run this, but how I thought I'd do this was put everything in a Python notebook, which I'll talk about later on, and then go through, I guess, some of the ways that I use and that other people use to access a lot of these online data sets. This would have been possible without an awful lot of help from Kelsey and Claire from the NCI. I can't see if they're online at the moment. I'm hoping that they are, so that any NCI related questions I can field over to them. So as Stuart said, this notebook is available online through the GitHub page, so grab it. And I'm just sort of going to give basically a general introduction about this project and then move forward. I might even share my video and then you can see how dorky I look with my headset on. There we go. Okay, so sort of represented here, I guess, are primarily four organisations, and I'll sort of go through them one by one. The first one, I guess, the main one where all the data is sitting is the Research Data Storage Infrastructure. So they provide all the online storage and capacity to host a lot of our Australian Earth observation data sets online, and it's that infrastructure that we'll be accessing today through this notebook. There's AusCover, which is really a virtual network for Earth observation data sets across Australia. A lot of those produced by universities, state government agencies, including Queenslander City, where I hang out a fair bit of the time, in New South Wales OEH, as well as CSIRO and Geoscience Australia. There's the NCI, which is just a big cranking computer, biggest in the Southern Hemisphere, and they provide a lot of the compute capacity for some of the AusCover products, as well as the interactive environments, which I'll talk about later on. And finally, there's the Australian Geoscience Data Cube that many people have heard a lot about. So it's really facilitating the operational processing, interactive analysis of a lot of the national Earth observation data sets. And we'll plug into some of those, not through the AGDC interface, I think that'll come as a later webinar, but directly through access across the NCI web services. So working together, these groups, I guess, help process, store and catalogue a lot of the Earth observation data sets nationally across Australia. I'm doing a lot of these, this entire notebook is being done remotely, so anyone can run it on their own laptop, their own desktop, mobile phone, whatever. But if you really want to get in and dirty and process large amounts of data using NCI compute, then the way to do that, or one of the ways to do that, is through the NCI Virtual Desktop Interface, or VDI. And that's basically an interface that you log into remotely. You get a remote desktop on your computer, and there's a whole lot of standard tools and software there, and you've got direct access to the NCI file system. If you're interested in looking at that and accessing that, and really if you're doing research, probably the best way to do it, then click on the link in the notebook on the GitHub page on how do I get VDI access and follow that through. In this talk, I'll be talking a bit through various service interfaces. So on the NCI, there's a number of ways of discovering data. The main one, I guess, is GeoNetwork. That's used across the NCI. It's being used across AusCover, and it's a catalogue service for capturing metadata from files and allowing that to be searchable and discoverable. I'll show an example of that later on. And then there's the Threads data service. So it's a data service, I guess, which provides a number of protocols. OpenDAP we'll look at here, but also direct HTTP download connection, OpenGeospatial, OGC web services, and the ability to connect by multiple ways to access data. So you can connect from your GIS package, or you can connect from Python or whatever. AusCover itself uses Threads GeoServer, and we also have FTP and HTTP services to deliver a lot of the data. So I'll connect through some of those as well. So almost on to where I am. I'm going to be using a Jupyter notebook. If people haven't seen Jupyter notebooks, it's kind of what IPython notebooks turned into. The Jupyter project have taken over the front end. So it's basically a web notebook. So what you're seeing on your screen is what I'm seeing in my web browser. And it's basically an interactive data analysis and computing environment that supports over 40 programming languages. So it's a really nice open source way to play with lots of these packages. And if you haven't used it before, I'd probably recommend looking at installing it via Anaconda. So it makes it very easy, particularly on Windows, to get up and running very quickly. and managing all the packages that you need. So it's a great way to start looking at data. So here I'm going to basically cover three main topics. One is looking at how you access some of the Joint Remote Sensing Research Program Landsat seasonal mosaics. They're sitting up here on the QSIF data store, sitting on Polaris, and we'll use basically GDAL to access those files. Then we'll look at accessing Landsat data as well on the NCI using their thread server and OpenDAT protocols. And then we'll finally have a quick look at capturing some MODIS data and look at a time series example, so how you would programmatically go through the catalogue. Those last two examples are also, and this notebook as well, are all hosted on the NCI training site. So if you follow the links there, you should be able to get to them. You may have to get an NCI login to get there. I'm not entirely sure, but there's a whole host. Actually, no, those ones don't. They're all sitting on GitHub. So there's a whole host of NCI resources which I'm not even going to touch on, but are really worthwhile having a look through. One of the main ones, I guess, for the broader community is how you can access a lot of these things using your desktop GIS package. So whether that be ArcMap or QGIS. There's some NCI QGIS examples, but the same thing works for ArcMap, where you can just connect in through a web mapping service interface or web coverage service interface and get data directly into your GIS, once again without having to download massive files. Okay, so all this, if you don't live and breathe this stuff, all seems a bit complex, but there's plenty of help at hand through training on the NCI. There's notebooks available, there's support, and there's this great community here as well, which, there's varying levels of skill and capability across the entire community, and many people are really happy to help with getting going on this. So I'll start off with some of the actual examples. And the first one, I guess, is using GDAL to access some of the files up here. So within a notebook environment, I guess there's, if you haven't seen it before, a Jupyter notebook has basically a cell layout. So the cells that I've been going through up here, if I double click on it, it'll change into horrible markup. So basically it's just marked down. So you can have a text or markdown field where you have information sitting in there, but you can also have a code field. And this field here is a Python code field, and it's just basically saying, okay, can I import a number of these Python packages, requests to connect to web services, raster.io, which is basically a wraparound GDAL to make it a bit more Python friendly, NumPy for doing numerical analysis, and matplotlib, which we'll use to plot a lot of the things up. So we can just Shift Enter, run that, and those packages have been imported. So let's open a data set and get some information out about it. Once again, if anyone's got any questions along the way, type them in the chat box, or that's probably the easiest way. We'll have a Q&A session afterwards. But in this first example, I'm connecting using this cool virtual file system driver for GDAL. So GDAL, the Geodata Extraction Library, has a number of virtual file system drivers. So you can obviously connect to a TIFF file. You can say, GDAL connect to my TIFF file sitting here on my desktop. But you can also connect to a remote file system using a VSI curl driver, and that basically enables GDAL to basically look in and just grab the bit of the file that it wants. You don't have to download the entire file. So these files are 18 gigabytes, and you'll see that I'm not downloading them, so it would take forever. But there's also other virtual file systems as well, which are worth looking at, so you can connect to zip files and things like that seamlessly. So what we'll do is we'll connect, in this case, if you go to the queensland.auscover.org page, you'll find you can go to or follow an HTTP link, and you'll find that there's this file. It's a South Australian mosaic, Landsat 8, reflectance mosaic of South Australia. I just add this little virtual file system driver in front of it, and then I just go raster.io open, send it that path, and then ask it how many bands and information about the file. So if we run that, we connect to it almost instantly and get the data that we want out. So it's a fairly big raster. It's 6 bands. It's 16-bit data, and it's roughly 50,000 by 50,000 pixels in size. One of the trickier things that you have to handle yourself with a lot of these packages is converting between, I guess, real-world coordinates and pixel coordinates. So most packages will show you some way of doing that. We'll show you some with a bit later on, but these ones here with raster.io, it's got a function which sets up a affine transformation class. So as a simple example, if we run this here, we can do a forward transformation by just doing a matrix multiplication with the matrix, which is basically attached to the data set that I've opened. So you can do a forward transformation, convert pixel 00 on an image file to a coordinate system, or you can convert backwards. And we'll do a bit of this here to find out which chunks of the image we want to extract. So if we do this and we pick a subset over, say, Port Augusta, I've worked out on a map that this is the top left and bottom right coordinates. We do a transformation on that, and then we just read in a subset over within the window that we want to look at. So rather than downloading an 18 gigabyte file and try and open it, we can just run that bit of code, and there it is. I've extracted a data subset from that in a matter of seconds. And we can display that if we want by scaling it and plotting it up. So here we go. This is the Port Augusta sitting in here. I just sort of picked this because it's sort of interesting. It's got a bit of water. It's got a bit of no data here. There's some clouds that would have been detected in the imagery and then masked out. And on the hills, we've got a slightly more foresty. We've got some grazing environments across the side here. One of the tricks when you go to show this imagery, particularly using Matplotlib, is that when you read the data in, I'll scroll back up, it comes as band sequential. So you've got 3 bands, each 396 by 1500 pixels. So Matplotlib needs that the other way around. It needs a band to lead by pixels. So that's why there's this crazy numpy roll axis call in here, which basically flips the imagery from band sequential to band to lead by pixel, is what we're doing. So if you're wondering why that is there, that's there to make Matplotlib work. Okay, so we've got a subset that's sitting here now as an array, a matrix sitting in memory. And I'll do NDVI because everyone does NDVI as a hello world example. So let's say I want band 4. It's my reflectance data subset. And it's the first band that I've extracted, because remember up here I just extracted, I forgot to mention that, bands 5, 4 and 3. So this subset is bands 5, 4 and 3. So if I basically build a virtual band 1, a virtual band 3, and then I calculate the NDVI by the usual formula, band 4 minus band 3, band 4 plus band 3. And then I fix up the not a number values because we want to mask those out. Plot it up, plot the figure, put a color map, and then add a title to it. And you run that, and we do the maths and we get an NDVI plot. Now, just to add a bit of excitement to this sort of hello world example, I put a histogram up here as well because we're in a numerical environment. We can do more than just do NDVI. We can compute a histogram with just one more line of code. So I basically give it the NDVI, I flatten it out, compute a histogram and plot it on here. So you can see that the range of NDVI values that we're seeing across this scene is roughly from 0 to 0.5, with the median or the mode is sitting up here at 0.25. But because you've got your data in memory, obviously you can play around and do a lot more analysis with it. And it's kind of cool. We can do all this without actually having to have any of these files locally. If you do want to have a file locally, and I just threw this in as an example last night, you can also run the usual GDAL utilities. So if you follow the link in this notebook, you can find GDAL. They're available for Windows or Linux or many operating systems. And one of the most useful tools, I guess, in that toolbox, the one that I use all the time, is GDAL Translate. So it will translate between file formats. It will translate between TIFF and NetCDF and HDF and so many MB format, a whole lot of different files. But you can also clip and subset out of that. So, and you can run that on the command line. So this example here, we use GDAL translate to clip that subset from the 18 gigabyte parent file sitting on the server. I'm going to resample it to a 250 meter pixel size, just say because I may want to be doing some analysis I want it to correspond to Modus pixel size, for example, and I want to change the file format to Kia because Kia is cool. Okay, and so to actually run that, it's just a call to GDAL translate. Output format is Kia. Here's the window that I want to extract the data from. I want to resample it to 250 by 250 meter pixels using an average method. This is the file that it's going in. Once again, it's that file on the server, and this is the file that I want to put out locally. It's Kia file, and so I can run that, and it's done. So it's connected to that 18 gigabyte file, and it's extracted the file, and it's run that resampling on that and changed the format. I can check that that's true by running GDAL info on that file. And you can see that the window that came in was 1500 pixels by 796 pixels. So that was the Landsat 30 meter resolution. The final resolution at motor size is 186 by 96 pixels. And there's a whole lot of information that's sitting in that file. So you've got all the coordinate details. You've got the entire processing history has come across as well. So that's embedded with a lot of the joint program files. We embed processing history in the file, and that obviously gets translated across by GDAL translate. And then you've got all the information you need about pixel scalings and offsets to use it. So instead of, if you've got a research area and you want to do more analysis locally or have a file locally for one reason or another, it's very easy just to chop the bit out that you want and bring it down. So this code up here, the GDAL translate code, if I go up to the top, is what you'll see if you follow, for example, Chopper, a little web tool that we've developed. So it just connects remotely. The user draws a polygon on the screen, and then presses go, and it basically just runs GDAL translate in the background. It's pretty easy. Just to follow up with an additional example, and I'll go a bit more quickly through this. One of the things that a lot of our users are chasing is to look at, for example, how much bare ground is over a region. So you work that out by building a cumulative histogram of bare ground. So once again, on both the NCI and locally here, there are fractional cover products. In all those fractional cover products, there's a number of bands. You can read the metadata. The amount of bare ground is in band 1. And in this example here, we're going to open a fractional cover file. We're going to read out the bare ground out of that through the window that we were looking at earlier on over Port Augusta. Print some information and then plot a cumulative histogram. So we'll build a histogram and we'll do cumulative equals true and plot that to have a bit of a look at the cumulative distribution of bare ground. Let's see how much of that area that we looked at earlier on is covered in, has less than 20% bare ground. So we'll run that, connect to the file, build the plot. Once again, it runs in seconds. And we can see that over that area around Port Augusta, roughly 20% of the area has less than 20% bare ground, for example. So it's fairly easy to imagine you can run this obviously over any area in Australia reasonably quickly and get the statistics you need back on, for wind erosion or water or things like that. If we want to work out where those really bare areas are, we can also obviously plot up the data that we've just extracted. So it's the Port Augusta area, bare ground. We can put a colour scale up here. So these brown areas are highly bare, and we see the highly bare areas are really around the salt lakes. And there's been some areas of clearing or something that's happening down there. I'm not quite sure what's going on, but you get a whole lot of tools to do analysis. Finally, another use case, I guess, is to look at the full time series of data as well. So this example, I won't go through every line of code, but basically there's a research property in Queensland. It's called Spyglass. It's quite a large property. It's about 60,000 hectares in size. This is a fractional cover image over it. It covers this riparian area here as well as larger bits of the surrounding area. And if you look at the full time series of Queensland, over that, there's about 2 terabytes of data if you look at all of Queensland. And obviously a user doesn't want to download 2 terabytes of data. So it's pretty simple in some ways to, there's a bit of code, I'll scroll through it here, to connect to the data set and download the information that you want. So this example here, I'll let people go through it in their own time after if they're interested, but we connect to the actual threads catalogue put out by AusCover. We go through that catalogue, find all the imagery, and we go through year by year, connect to the data set, work out the area that we want, extract it, pull it to our local server, work out statistics. In this case, we work out the median, the mean, the standard deviation, the minimum and the maximum over that entire property. And then we format it into a table and we plot it up. And let's just start running this example because we need to access about 120 images, as I said, about 2 terabytes of data. So it takes about 15 seconds, I hope, to run. And once we get the data back as well, there you go, it's come back now. It's taken 13 seconds to pull that data back over our site. So we've got time series statistics. In this case, we've got the date or the season, min, median, mean, maximum and standard deviation over that property for every year from 1988 through to 2016, first quarter. And we can plot that up. So the blue dots are, in this case, the maximum or the 95th percentile bare ground across the cattle property. And you can see that some years, for example, 95, 96, 97 was very dry. It was a drought year, so there was an awful lot of bare ground. And the 1999-2000 wet season was very good, as was the 2011 flood in Brisbane. And you can plot up those points. In this case, we fit it using we join the points together using a spline or a linear fit, and I was just playing around and we fit a polynomial to it. So there's a whole range of analysis you can do, with time series. Obviously you could start doing time series decomposition and things like that. And you can look at different areas, so it'd be just as quick to run this analysis over, another property in Queensland or another sub-catchment somewhere. Once again, in a matter of seconds, without having to pull 2 terabytes, download 2 terabytes of data, try and manage that locally. So just with a few simple tools, you can do some pretty powerful analysis. So now we'll move on to, hang on, what am I talking about here? Data services. Okay, I put this in as well, just because it's cool. I mean, we're a raster group, but I thought I'd just show that GeoServer, the AusCover data, I guess, includes not just raster data, but also field data as well. So if we have a look at the terrestrial laser scanning sites and we do a request through GeoServer, we can also, rather than downloading the points locally, we can very quickly build a web map, for example, a little slippy web map, which has got all the sites where we've collected terrestrial laser scanner data, for example, over the sites as well. So for vector data as well, remote access is very much a programmatic thing as well. It's a few lines of code. I've got a map with all the points on it. Okay, how are we going for time? I'm waffling on. NCI data analysis. So we'll now, I guess, replicate some of these examples using the NetCDF interface onto the Landsat 8 data archive on the NCI. So the Landsat 8 data sitting there is produced out of the Australian Geoscience Data Cube, Geoscience Australia data as well. Once again, we import the same libraries. I don't really need to import them again, but I've just put them there for completeness. And except in here, we're importing a NetCDF4 driver as well. So that allows Python to talk to NetCDF data. And we can connect to our NetCDF data using a URL which I'll show you how to discover later, but a URL through to a Threads catalog. So we'll connect to the data. That's done, we're connected. And we can find out information about the products as well. So here's a 4000 by 4000 pixel size subset of data. Within that, there's a number of variables. So there's X and Y and time, obviously. There's a coordinate reference system. And there's also all the bands. So there's Landsat's bands 1 through to 7, all with the various attributes attached to it. So similarly as before, we can extract data. So we can extract a subset. In this case, we want to extract from the 1000th pixel to the 4000th pixel in the X direction, and from 0 to 3000th in the Y direction. And so we just basically call the subsetting tool. We run that. That will run. It will connect similarly over the network, and we've grabbed a data set, and we can plot that up in a similar way as we did before. So this data set is a bit bigger. It takes a little bit longer for Matplotlib to render it. But here we've pulled the blue band over this data set. You can see that most of the areas are very low, and there's a couple of very bright blue responses. So we might think, oh, so what are these? We want a true color image. So we can plot a true color image using the same band combinations as we did earlier on. So once again, we read in band 4, band 6, band 7. We scale that and do the same thing. We plot the image using Matplotlib image show. So let's run that and have a look at that image in beautiful true color, or a false color composite anyway. Hopefully that is going to run. It's running. There we go. And here we are, where you can see those bright blue areas are in fact lakes, water points. We've got a lake system down here. And we're in Spinifex country. There's a few fire scars that have moved across the landscape. So the access using the NetCDF is once again very similar than using the raster IO interface as well. They're just different ways of accessing the same data, depending on the format that the data is sitting in. So we'll close that file, neat and tidy. But what I want to get onto now, I guess, is how you find this thing here. So actually how you find the data set that you want to look at, because that looks like an obscure URL. So if you are searching for this data, the best way to look at that is to basically go onto the NCI portal. The NCI portal, or the Geo network, you can get to by following this link. I won't go there right now, but I've got, or Kelsey's helpfully putting screen grabs into this discussion here. So that's what you see on the home page. In this case, we're interested in looking for Landsat data. So you do a search in the search bar, you fight the mouse for Landsat, and you'll get a number of different Landsat products here: Earth observation, water observations for space, fractional cover. And we can click on any of these and get an overview of the metadata record. So if you click on Earth observations, you get to see this page here, and you get a metadata record. You get the spatial extent, the temporal extent, and a whole stack of information about it. And it also gives you that link, which is the one we use above. So it's got the link to the catalogue on Threads. So you navigate to that link, which is the publicly available catalogue, and you reach a page like this, which is on the Threads server: Landsat data, scenes and tiles. And we're, in this case, interested in looking at the NBAR data set, so the surface BRDF corrected data. So you navigate, you follow that link, and once you get to that link there, you'll find a URL in that page. So the Landsat 8 NBAR data set has got a link in your web browser: Threads catalog, RS North tiles. And that's the catalog, and that's the URL that we can use to discover data within that, discover files within the catalog. All right, so this example here, we're going to use Siphon. It's another Python package. There's so many Python packages. Siphon is really, really useful for looking and searching across threads catalogs, which is exactly what we're using here. So from Siphon, we import catalog and NCSS, date time to handle times a bit more effectively. And we put in the catalog URL. And then we can use Siphon, in this case, the Siphon catalog function, to connect to the catalog and list the data sets. So that's connected. It's grabbed the data sets, and let's have a look at the first 10 data sets that we're getting through there. So we've got the Landsat 8 NBAR data sets for a variety of tiles across Australia. For each of those points, we can also have a look at the endpoints. So Threads provides a lot more services than just HTTP. It provides web coverage services, it provides HTTP, it provides a web mapping service, it provides OpenDAP services and many others. In this example here, we'll probably be interested in the OpenDAP service over the top of that. But if you're connecting through a GIS package, you'll obviously want to connect to the web coverage service and suck the data directly in. So we want to query this catalog and find out, for this example, which Landsat scenes are within some bounds. So we've got a query polygon. In this case, we want to find out which Landsat data sets in this catalog are between longitudes 136 and 138 and latitude -29.3 and 27.8. So we've got a polygon, which is a polygon object, and then we can run through here the catalog and work out which polygon, which Landsat dataset intersects with each polygon. Now I should have started that a little bit early because this takes a little while to run, but so I'll just keep talking in the background. I might sing a song to entertain you. So that's running through at the moment, and here we go, it's found a couple already. It's opening, it's looking at every file, it's looking at the bounds within that file, because if we scroll up here, I think we showed that. Each file has obviously bounds associated with it, and we've got bounds within the polygon, and so we can have a look and see if the bounds in the file intersects the bounds of the polygon. We can print that out and grab that file. So as we steadily run through the catalogue, we're finding more and more Landsat data, which is matching our query, and we're just appending that to a variable called matches, and that'll allow us to then connect to all of those down the track. While that's running, I'll run through a cool feature of OpenDAP, which we'll use here. So we can, in the previous example, I showed how to just pull out a subset, but you need to basically extract every pixel within that subset. OpenDAP allows you to, let's say, pick every 50th pixel, which is what we're doing here. So instead of reading in that entire 5,000 by 5,000 image, I just want an overview to have a look over the top of that. And so I can basically just say, well, give me every, this is a NumPy indexing thing, give me every 50th pixel in that entire file, and give me every 50th X pixel, give me every 50th Y pixel, and let's plot that up. And so that means that, you know, you don't run into problems of having 8 images, huge images sitting in memory if you just want to do a quick overview picture. So when that's finished running, it's still running now, we'll run this bit of code, and that will pull out every 50th pixel over the top of that, plot it up, and hopefully join them all together, and we'll get an image of those files that we've discovered at the other end. I'll just put an aside in here that within AusCover, and possibly more broadly across the community, we're looking at ways of, I guess, improving this discovery. So locally within the joint program, for example, we capture all the bounds of all our different image data sets across the Landsat, Sentinel, MODIS in a PostGIS database. And so it becomes a fairly quick SQL query to pull things out like this. Here it does take a little while because we need to read every file, find the bounds of each one, and then do the intersection manually. So there we go. That's finally finished. So we've passed the catalogue. We've got those tiles out. CPU didn't take very long, but it was just a fair bit of time having a look at getting the bounds out of the files. So now this bit of code is running here, and we'll soon see the data that we've pulled out, and hopefully it will all join together quite nicely. Slight pause. There we go. So this is kind of cool. Here's our 6 scenes, the 6 that 1, 2, 3, 4, 5, 6 that the example pulled out, and you see they've been resampled to every 50th pixel, so they're not enormous, and they plot up reasonably quickly in geographical space. And from here, then it's very quick to do further analysis because we found our data, and we can run queries on arbitrary subsets across that. Okay, finally, let's have a look at a Modus time series example. So I looked at a Landsat time series. There's a fair bit of AusCover sitting on the NCI catalogues. In this case, we'll look at the Modus fractional cover data. We'll connect to that data set, once again using threads in the same process we used before. We've got a small function here that if you basically define a function, you give it a data set and a bounding box, then it will extract the data within that bounding box. So we define that function and then run that function down here on a box. So once again, we connect to the data, we extract that bounding box, and here's a Modus fractional cover data set over that bounding box extracted. That's kind of nice, but let's say you've got a presentation due tomorrow, as is always the way, and you want to do an animation of fractional cover fairly quickly. So what you would do is you'd basically go through the entire collection, and you'd basically grab that plot and save every plot as a PNG image. So let's run through and do that here. So in this case, we grab the most recent 15 Modus fractional cover scenes, we pull them down, we do a plot. We don't show the plot, we just save the plot, in this case locally on my machine as a PNG file. Okay, so that runs, and when that's finished running, I will have 15 PNG files on my local machine. You can then use your favorite image animation package. In this case, I'm going to use good old command line image magic to convert the PNG files to an animated GIF. Wait for that to finish running. It'll run soon. There we go, that's finished running. It's pulled down all 15 Modus scenes, and then I can run that animation. And conveniently, here we go, that's finished running. I've built an animated GIF, and that's being displayed now in the browser. So this is Modus fractional cover, changing over time. Not an awful lot in this example, but we've built an animated GIF and displaying it from data that we found remotely. You don't have to do this spatially. You can obviously extract a single point as well. So as we did before, we defined a function called getArea. Here we've defined a function called getPoint, which queries a point. Give it a data set in a Latin long, it will return the point. Looks a bit like this. So if you say getPoint on a Modus data set, 54, so 54% bare ground at that particular date. And so we can obviously iterate that function over all the data that we've discovered in the catalogue. So for endpoint, in all the endpoints, get the point, add it to a variable, and then we can plot that up. And once again, we get a time series plot. Oh, that's still iterating. Sorry, I pushed that a bit fast. That's going through quite a number of endpoints in the catalogue, drilling the point out. Once that's completed, then we'll plot up a time series, I hope. And then if that's completed, then all the code, there it is, has worked in this notebook and nothing crashed. And it's a win. So this is fractional cover of bare soil. I should have handled no data a bit better. So values of 0 here and no data, they should be masked out. It's really easy to trial up. And yeah, once again, we've got a time series coming out the other end. So, and we've reached the end of the notebook and all the coders work, which is somewhat magical. Thanks, Claire. And that's kind of the end of what I wanted to say. I sort of hope I've got across. I mean, a lot of this is fairly technical. I'm not going to the code. I'm happy to talk one-on-one if you email me or chat afterwards. And I guess the point I want to make is that, look, there are a lot of services. If you go right back up to the start and have a look at all the services available on the NCI and on the AusCover portal here, there's a lot of data sitting there. You don't need to pull it down locally to do stuff with it, okay? You can just connect to it, you can run things, and it's all good. With that, I'll stop and I'll take any questions.
Cool. Thanks, Peter. It's Stuart Pinn here again. So if people do have questions, the way we'd like to handle this is either type into the chat box, or if you see the little person with their hand up at the top of your screen, click on that and you can raise your hand, and what we'll do is we'll activate microphones from now on. We are going to record this and can do some follow-up as well. It'll be the first presentation, and I hope several from people in this field. I think we'll all agree Peter did a huge job in preparing that and putting a massive amount of resources together. Just while people start asking questions, I've got one to begin with, Peter. You've shown a lot of the back-end processing in terms of code-based processing. Is this something that we're going to see progress to packages like Envy and Imagine and, I guess, QGIS, where you can set up these sort of operations in an object-based way without having to go through all the coding?
Yeah, definitely. In fact, I'd kind of really like to run through some QGIS and ARC examples further down the tracks. I think, yes, I mean, we're showing very much coding here and playing with the data in a Python notebook, but I think this data will really start having value when the community more broadly can easily access it through their desktop GIS packages. So there's nothing at the moment stopping people from plugging into, let's say, the seasonal mosaics, for example. So you can connect to the web services through that and get coverage over Australia into QGIS. I think ARC still doesn't quite support. The latest version might support web coverage services with the EO extensions, which is what we use, but they certainly will down the track. And then, yeah, the sky's the limit.
Thanks. Right, there's a couple of questions in the text there. Again, if people have got questions on audio, just put your hand up and we'll try and get to you to answer them as well. So there's one from Gareth Williams there about your GDAL virtual file functionality.
Okay, yeah. Actually, I'm not even going to type in, I'm just going to answer these. Okay, so I'll go back to Hayden first. I just want to check that I have this correct. Is this NCI dataset processing analysis tools and data only available for processing of the local system? No. So the NCI, if you log in through the virtual desktop environment, will provide all the tools to process. Many of the Python packages will be there when you start, and you can install packages into your local area. But can you utilize this as web services from external web application? Not directly. So there is, if you have a look at that GitHub site within AusCover, for example, there's some work there on web processing services, which the idea is to can up a number of these routines. So let's say you want to send a request to look at a time series. You'll be able to post some geometry, a wicked geometry or a GeoJSON geometry to a URL and get the time series back. That's what's running, let's say the NRM Spatial Hub, for example, or the Veg Machine, is that there's some of these services are wrapped up, and there's a web API, I guess, which run some of this in the background. So I'd be certainly very interested in hearing what sort of services people would be interested in wrapping up, I guess, for API access, so you can build tools on top of that. From Gareth, GDAL virtual file system. The reason I use the GDAL virtual file functionality in that point is that the files that we've got sitting on Queensland are as GeoTIFFs, not NetCDF files. And so OpenDAP requires things to be in NetCDF typically. So we put them up there as GeoTIFFs for a number of reasons. When we started doing it, that's all the GeoServer would use, but also we had a lot of users that had trouble with the NetCDF file format. OpenDAP's cool. There's no, the limit here accessing things is really the speed of your network. So OpenDAP isn't any faster. In fact, I'd contend that it's probably slower than the GDAL virtual file system for accessing some of these files. But you need a bit more testing on different platforms to try that out. But yeah, you can, both methods are cool. We've just got data in TIFF format, so that's why we're using GDAL. Richard. Oh yes, Sentinel. Yes, I agree, Richard. It's that data integration that where things become really interesting. So I kind of ran out of time to do it, but I would really like to, for example, on that time series plot to show rainfall, for example, and that's obviously quite doable. You just connect to one of the other, a climate data set that's being hosted on the NCI, and then plot that up as well. So certainly we'll do that in the future. I think at the moment the Australian Sentinel archive is still being sorted out. I'm kind of hoping that it'll be in a state where we can start doing a lot of this programmatic stuff to it in the next week or so. Okay, Eric, Landsat data in the notebook. Yes. So if you're sitting, if you have a login to the NCI and you have an allocation, then the Australian Geoscience Data Cube code base is the way you should be interacting with a lot of the Landsat data that's sitting on the NCI. It makes that whole discovery and extract seamless. I'm hoping, in fact, I'm sure it will be one of the next webinars that we'll see. Someone from GA and the NCI and possibly myself giving some AGDC examples once the version 2 API is all settled down, because I think that's really exciting, and that makes a lot of this access, discovery, trying to work out where things are, disappear. So entirely agree. The AGDC is going to improve a lot of this Landsat time series processing no end. Stuart, Sentinel. Okay, Stuart's answering Richard. Thank you. Lots of interest in Sentinel. That's good.
So, did you want to address Robert's question about firewalls?
I don't know. Well, I should know because I'm at the city, but that's why I'm doing this from UQ. So a lot of I'm not sure actually, Robert, how there is, I know Raster.io has, you can set up proxy within that. So I'm sure the Raster.io examples, GDAL, will work okay. And I know from, or we know from using QGIS that it is possible to proxy the GDAL calls through the corporate firewall and connect outside. if anyone there knows how well the OpenDAP, if you can set up the NetCDF OpenDAP drivers to proxy through a firewall, I'd really like to know. I haven't tried it. And Phil, who can get NCI login at the moment, follow the links, and I don't know, maybe Kelsey or Claire might want to jump in to the NCI login question. I'm not really sure.
Yeah, looks like Claire's typing. There's also, I just put up the link. That's the link on the NCI page for registering as a new user. So just, okay, there's a response there from Claire as well about logging in and firewalls. Again, that's a little bit out of the control of everybody here. It's an institutional response again, but it's something that we can pressure our institutions if we know enough people want to use it. Just while we're going through and asking questions, as we get towards the end of the presentation, it'd also be helpful to hear from people what they would consider as future follow-on webinars from this. Peter's actually mentioned, I'd written down 3 in the course of what he'd said, so if anyone's got other specific ideas what they want to hear about in terms of access to data sets and processing capabilities, please make a suggestion towards the end of the presentation today. All right, I'll just go back to Peter now.
I managed to mute myself. Okay, so Claire presented what Stuart said, so any research can get access. Yeah, the trick's explaining to the NCI. So if you follow that link that Stuart sent in there, click on that and follow the registered new user and go through the steps and, you know, basically build a case for why you need access and go from there.
All right, looks like we're slowly getting to the end of questions. Claire's adding a lot more context there to help us expand the use case. The more people that start using these systems and national data sets for their activities, the better it is for us improving them over time. We are going through a period of refinement with AusCover in terms of data sets and how we serve things, as will some of the other infrastructure facilities. These are one source of large-scale online data sets, and other, I guess, sources are things that we could cover in future webinars in terms of there are open public good services that can be used, and there's also commercial ones as well. I'll just hand back to Peter now because there's some questions from people about access to the notebooks and that, and where they are.
Yeah, thanks, Stuart. So it was at the top, but I'll repost it again. So this notebook is sitting on the AusCover GitHub site, and it's also accessible through the NCI training site as well. So there's a number of spots where it will be. And feel free to log issues with it on GitHub, and we'll work on it. But hopefully we can start adding to these examples as well. Oh yeah, thanks Claire. So yeah, if you follow that link there, you'll grab the notebook as well if you've got an NCI login. So yeah, and I think if you are installing, if you are running this notebook locally, you'll see this. It does rely on a number of Python packages which may not be installed by default in Anaconda or your install, but when things break, just have a look at, if the package doesn't import, just have a look at it, and you can either, do conda install on the package or pip install, and all these packages are available. I certainly didn't go out and compile anything from source to get it going here. I just installed it using package managers, so it should be reasonably easy for most people to grab this notebook and get going. But yeah, if there's no more questions, we've almost reached the end of our time.
Sure. I think maybe a suggestion, Peter, is that we leave, we're just before 12 now, just leave the page up until just after, maybe, let's say 12:01. And if people want to make any suggestions, about how this was delivered, what worked, what didn't, and then also possible future topics as well. We will put these up on the AEOCCG website afterwards, and I would just encourage everyone just to keep an eye on that in terms of these webinars. Just before we close though, another advertisement. We are running a process for setting up a new National Earth Observation Community Plan, which is going to need input from all sectors of Earth observation data users, which I think is pretty much everyone on this webinar. So please keep an eye on our website for news about that, because now more than ever we need to act as a coordinated community to ensure that we get access to these great data sets and resources over time. You can't just build these and expect them to continue operating. We've got to keep justifying them. So please contribute to that when you see notes about it. I would again like to thank Peter and also Claire and the other NCI staff for putting this all together. We had an issue last week, it's solved. Today ran seamlessly, which is just amazing for a webinar for these sorts of resources. So excellent work, everyone. Hopefully we can continue that over time, and we'll keep building on this in the future. So with that, I think we'll probably stop our video and audio feed now. And if you've got questions, type them in or email to us. And as I said, the recording of this will be up online. Peter's got the documents and notebooks up on GitHub. Provide some comments there as well. So thanks, Peter. Thanks, Claire, and also